Hello. We are going to play with the Python's arguments during function invocation and definition. Let's see how Python uses its function arguments. Some details, okay? Let's edit a function. Add up. It's a very simple function. You can see it add up x and y and return the result, the addition. Okay, it's very simple function. Let's call it. Function invocation is finished by the parenthesis. We give it parenthesis and it will invoke the function. Let's see. Add up. It's missing two required positional argument x and y. Okay. Of course, it cannot pass. Add up 1 and 2. This is the correct invocation. We get 3, of course. Let's check it can add up to 10 and 20. It's 30. Okay. What about we want let's see, we know it add up x and y. Y equals and x equals the result. This is very casual because y happen come up first if we just happen to be slow memory. Y come first and x come later, so we give it y first and x in the second. It add up. What's happened? It means, let's check the function definition. This is very normal function. This kind of function arguments happens in many language, programming language. It uses first argument, give it a name x, and second y, and it uses the name inside the function. So the argument in the same time is in the local namespace of the function. Inside the function, they exist, they live inside function and add it up. What just happened shows when we call the function, we didn't necessarily have to follow the positional sequence. We can give the name, and Python interpreter will find out what we're giving them if we use name. So this is somehow relaxed. It gives some convenience, maybe not very much, but a kind of convenience. What about x? It's a type error because the first number supposed is x and x already get value, so the second named argument shouldn't happen to be x. Okay. Then what about we want add up be a little bit powerful, add up many numbers. We use it this way. Have a value start from 0. Or we can use it add up x, y, and for I in ARGS is commonly used name. It means arguments, the plural style of argument. Then we return R, of course. This time we make it a little bit powerful. It can accept any number and add it up. Any number of integer and add it up. Let's see. And a big number. Okay, it had add them up. What happened in the function? ARGS, it gets an operator star. It's a wildcard. It means here it means unpack. It will actually inside function is packing when it got invoked. When it got called, the function get called, it will pack all the rest argument into ARGS. Star, if you look it as a wildcard, then it's anything following the X and Y. Okay. To make it clear, we print it out. And we print the type of it. We print the value of it. Okay. Then call it this way. We can see the type is tuple. Tuple is sequence data type, and its value is 4, 5, 8,000. This is the unpacking and packing the argument list. What if we have a sequence data type? For example, mul data equals for example, we want pass it to the add up. We can unpack it. Let's see. And we unpack it. It's a little bit confusing because we define the function, we use the star as wildcard, and we call it when we want pass a list to the function, we use it again. Let's see the result. We can see the list, the sequence data type actually unpacked into the parameter position. So the tuple, the ARGS is class tuple. It's actually for 5, 8,000, and then followed by the mul-date list. Then followed by the numbers in the mul-date list. This is the result. It's pack and unpack the parameter list. Let's see. Make it a little bit simple. We give it nothing but mul-date. It's okay because it's 3, 33 and 33 and 38. It will get X as 3, Y and the rest. Okay, so the tuple become the rest. It means this operator just unpack the list and put it in the position of during we call the function, put it in the position of the argument, positional argument. It's unpack the list. And when we define the function, we make it this way to get the rest of the positional arguments. Okay. And can we do it this way? We can do it this way. Still use the two number, and the rest is an empty tuple. And of course, if we do it in string way, make a string, we add it up to string because it can happen. See, it didn't check its type, check the argument type. Okay, let's define another function. Show the argument list. Suppose we have 3 arguments. And we print it. This is the function we gave it. We get A, B, C. Let's call it with the named argument. C equals A equals B equals. We call it in different sequence. See, if we use unnamed positional argument list to call the function, we know that the first is A, the second is B, and the third is C. But if we use the named argument, we can put it in different sequence. We give it C, give it A and B. Of course, we must give all of it. This will missing one required positional argument. So, how to relax it to accept missing argument? Let's redefine the function. Give it a default value. See, we gave a value in the function definition. This means it has default value, and not necessarily to give it. This time, A and B is offered during function invocation, but C, we didn't offer C, but C still has the value, the default value, default C. If we're missing another, then we got missing required parameter. Of course, we can relax it even more. Then we can use it this way. B got default, C got default, and A is required. And we can omit the name. Then we just talk about the packing and unpacking. Let's show how to pack something, how to use a dictionary as argument, because we have a dictionary, for example. B equals and C equals. Okay, we have a dictionary. Then how can we pass the dictionary to the function? We don't want to type it in by hand. It's very easy. We unpack it with a double star. We can see it gets value A is A in dict, dict. It means we can pack and unpack parameter like this. Let's change the, let's use another function, definition foo. A has a default value. It's string A. B has a default value. It's B. And C has a default value. It's C. Very easy. It's okay. Let's see. We are expecting there might be more named arguments. We print type of argv. Argv is usable. Then we print out argv. Okay. Then we give it sum. We don't know what sum and other. We can see argv is dictionary, and it has sum as and other as we specified the value for it. How to call it with the dictionary? This is unpacking a dictionary. Let's see what happened. B got duplicate. Yes. Let's say this function, it has 3 arguments with the default value, and it accepts named arguments argv as the rest argument. Okay. We call it with the 3 first arguments and the dictionary. Unpacking a dictionary pass it. So we suppose dA is what the argv. dA should equals to argv. It has A in dictionary, B in dictionary, C in dictionary, and the function foo got dictionary argv as this way. Okay. If we add marquee and value to parse it to it, it gets more. Okay. This is the function argument. Play with it. It's positional sequence and packing and unpacking default value, something about the arguments. Okay, actually we are following the official tutorial of Python. Okay, thank you. Bye bye.